I'm Claire, and welcome back to Simply Space. Today we are going to be talking about the different types of supernovae. Remember, a supernovae is the explosion of a massive star. In the Milky Way, there's about one supernovae explosion every 50 years. But in the observable universe, there are about 30 supernovae explosions per second. With that many, it is important to understand what distinguishes some supernovae from others. All supernovae fall into two categories, type 1 and type 2. The big difference between type 1 and type 2 supernovae is the presence of hydrogen absorption lines in their spectra. Type 2 have much stronger absorption lines for hydrogen than type 1, which just means that they have more hydrogen present in the explosion than in a type 1 supernova. We'll go into the different types of type 1 supernovae first. Type 1a supernovae branch out from the rest of type 1 supernovae because of the way they are formed and because they have a strong silicon absorption line in their spectrum. Type 1a supernovae are very important to cosmologists and make up actually 79% of all supernovae in the entire universe. You can find out more about these super cool type 1a supernovae in Simply Space's video, link right here. Besides the type 1a supernovae, there are only two more types of supernovae that are type 1. They're type 1b and type 1c. Together, type 1b and 1c only make about 4% of all supernovae. Type 1b supernovae have absorption lines for helium, which means that the stars that form type 1b supernovae just lost their outer shell of hydrogen. Type 1c supernovae don't have absorption lines for helium because their stars have lost both their hydrogen and helium shells. Now on to type 2 supernovae. The difference between type 2 supernovae aren't as clear-cut as they are for type 1, but they're still there. Type 2b supernovae are the first to branch out from the rest of type 2. And they make about 17% of all type 2 supernovae. Type 2b supernovae have an initial spectrum that contains a weak hydrogen line which later becomes undetectable. The type 2b supernovae also have a spectrum that is very similar to the spectrum for type 1b, while the rest of type 2 supernovae have quite similar spectra to each other. The type 2 supernovae that are left are type 2n, type 2p, and type 2l. Type 2n supernovae, which make up about 29% of just type 2 supernovae, are different from type 2p and 2l in that type 2n has narrow lines in its spectrum. N for narrow. It's kind of funny. Whereas type 2l and 2p have no narrow lines. Scientists believe that these narrow lines come from the exploding star having its light come in contact with either another gas cloud or another star before we can intercept that light and analyze its spectrum. Type 2p and type 2l also have obvious naming, as type 2p reach a plateau in their light curves and type 2l have a linear decrease in their light curves. Type 2l supernovae make up about 25% of type 2 supernovae, whereas type 2p make up about 30% of all type 2 supernovae. While the presence of elements and light curve patterns are good ways to classify supernovae, there is one more way that we can broadly categorize them. As mentioned in our video on type 1a supernovae, these supernovae occur in binary systems where there's a white dwarf and its massive companion, and the white dwarf is drawing mass from its counterpart. Then there's a nuclear explosion, and this nuclear explosion is what makes type 1a supernovae so useful to cosmologists. But for all other supernovae, they are created when a massive star of at least 8 solar masses can no longer maintain itself anymore through nuclear fusion. As a result, it commences a chain reaction that will lead to the star's core collapsing and exploding. And those are the main differences between the different types of supernovae. You know, some scientists claim that there are types 3, 4, and even 5 supernovae, but those claims have only been supported by a few select supernovae that really just don't perfectly fit the standards for a type 1 or a type 2. So overall, as long as you follow the classification system that we just went over in this video, you should be able to identify just about any supernova in the entire universe.